Hello everyone. This is in continuation with the topic testing of hypothesis. The next question is like this. A study is carried out to examine whether the mean hourly wages of the unskilled workers in two cities, Ambala and Lucknow, are the same. Means to test whether it is the same. And then the random sample of hourly earnings in both the cities is taken and the results are below. So sample mean of that each city is given, standard deviation of sample is being given, sample size is given. So let us just put all these things in terms of notation. I can call, since this is first city, I'll call this as x1 bar, this as s1, this as n1. These are both are large sample. This into this is also greater than 30, so large sample. This one we call it as S2, this one as X2 bar, and 5% level of significance, so it is alpha is 5%. Test the hypothesis of no difference in the average wages. So we are actually checking for two different cities about the average wages. So say the above is a test concerning with two population means. Two population means. Let mu1 is equal to mean or I should say mean of the first population. Mean of the first population, which is Ambala. Mean of first population, or rather mean wages of the first population. Then mu2 is mean wages of the second population. And that is Lucknow. So the above is a test concerning with two population means, and sample sizes are large. And hence we will use Z-test. Then the hypothesis, we are supposed to check whether it is mu1 is equal to mu2 or not. Alternative, there is nothing like more than, less than, etc. given. So alternative will be exactly opposite this, mu1 not equal to mu2. So it becomes a two-tailed test. Then the relevant Z-test statistic will be, write that in the next page, Z-cal under modulus will be modulus of x1 bar minus x2 bar minus of mu1 minus mu2, whatever that value is under h naught, the whole thing divided by standard error, where SE is standard error. Now mu1 minus mu2 means under h naught, if mu1 is equal to mu2, it implies that mu1 minus mu2 is 0. So this one, we can write it as x1 bar is 8.95. 8.95. So 8.95 is our x bar, and then 9.1 is our x2 bar. Mu1 minus mu2 under H0 is actually 0. Here it is. So this will become 0. We are supposed to calculate the standard error and bring that to the denominator. Let me just leave the space. Standard error is sigma, let us say, and that is equal to square root of sigma 1 square plus sigma 2 square. Sigma 1 square by n1, sigma 2 square by n2. And in this particular problem, we don't have the values of sigma 1 square and sigma 2 square, or standard deviations are unknown. So that will be replaced by sample variance. So this will become now S1 square by N1 plus S2 square by N2. Now if I substitute the S1 and S2 values, S1 is 0.4, S2 is 0.6. So 0.4 the square divided by N1. N1 is 200. That is available here. Yeah, N1 is 200 and N2 is 170. And here it is 0.6 the square by 175. So if we calculate this, we may get 0.053. So that is our standard error. So let us substitute that standard error in the denominator here. Now, if we evaluate this considering the modulus, we will land up with the Z calculated value as 2.83. Now, this is a two-tailed test and Z test. So we have to use that Z table value. Z tab is Z table value at 5% level of significance for a two-tailed test. That is known to be 1.96. Now we can come to our inference, the final step. Since Zcal, which is what we calculated here, 2.83. 2.83 is larger than Z tab, which is 1.96. We reject null hypothesis, which means we accept alternative hypothesis. That will end the solution for this particular problem. In case if you find the contents of this video to be useful to you, I request you to please like, share it with your friends, and also subscribe to my channel. Thank you.